present by scanning their badge at the station in the back of the room at the end of the session. So as a reminder, we will be doing some audience questions, so either speak out or we have a microphone here in the back. We'll go ahead and move to the next session on international standards, presented by Malcolm Airst, the senior engineer with the MITRE Corporation. Ladies and gentlemen, Mr. Airst.
Hey, thanks very much, Ben. Appreciate it. So I'm going to talk about international standards, how standards are codified, the different standard organizations, and my contact information is here. If anybody has any questions, just please raise your hand as I go along. I don't want to get to the end and then you forget your question. Please interrupt. So I'm going to define what is a technical standard, and then why should an engineer in an organization participate in standards development. I'm going to go through some of the international standards organizations. One of the problems is that there are multiple, sometimes competing standards organizations, and you have to pick the winning horse. You have to pick the right standard and family of standards for your application, and that takes some work. And then I'm going to talk about in depth an example, the Internet Engineering Task Force, or Ietf, as a real-life example of a standards organization and how they work and what areas they cover. I'll talk about the benefits to the U.S. and our international coalition partners, the benefits of standards. And I've had a couple of decades of experience working on coalition interoperability, so I can talk to that. And then some tips. So what is a technical standard? And I'm an electronics engineer, so I'm going to talk about technical standards. I was at a talk earlier this afternoon. They talk about behavioral standards and cultural standards. I'm going to talk about technical standards. So standards provide technical requirements, guidelines, or specifications. It depends on the standard. But the whole idea is to ensure consistency and interoperability of materials, processes, or services to make sure they operate or they perform according to the desired effect. And there are so many standards bodies. This is a somewhat generic definition. But today, standards are fundamental to today's technologies. Everything from GPS to Ethernet. They underlie everything that we have in society, technologies that we depend on. So very important here, standards create and define a common language, and they promote a common understanding and a reference point when discussing a given technology. So among people in a given field, or when engineers talk to the military, standards ensure that common language and common reference point. So there's two main types of standards. De facto standards are standards that are created usually by a single organization or a dominant vendor. Think of the Ibm Pc or the Global Positioning System, GPS. The US government with GPS basically developed it, codified it, and then published an interoperability standard for GPS. You want to receive GPS, you'll follow this 300-page document with many, many fields and defining right down to the bit. That's one example of de facto standard. Another example is the IBM PC. There wasn't that much documentation. It just, they came out with it and said, we're going to define a couple of simple interfaces like RS-232 or RS-485, and oh, by the way, you figure out how to talk to it, and it runs MS-DOS, and limited documentation, but vendors reverse engineer it. The other type of standards are de jure or formal standards. These are standards developed by the consensus process by a recognized standards body. Example is American National Standards Institute or IEEE. Typically, de jure standards define precisely what capabilities are mandatory and which are optional, and they often define interoperability profiles. So say, okay, if I plug these two devices or cables together, it will interoperate if you follow these rules. Many of the more formal standards body require working operational prototypes before they'll codify the standard, before it'll be approved. Ethernet is an example, voice over IP. Other examples are the plugs in the wall. There's actually a standard for those, and obviously different countries have different plugs, but they are standardized. So why should an organization participate in standards development? And this is a battle I fought many times in my career, because you have to convince leadership at your organization, why should we bother? What you get is you work on a standard, and it can take years to get the standard completed. What you get is an intimate knowledge of the technology. You understand how the technology works down to a very low level. You understand the common language used by developers of that technology. You become the go-to person, the source of corporate knowledge. I'll give you an example. I worked on network time protocol it's a way to disseminate accurate time of day over IP. I also worked on a live insertion spec for VME bus. The US Navy was developing radios of different types and switching equipment of different types that plugged into a standard backplane. And that backplane is defined by American National Standards Institute. But the Navy said, well, if we have a board fail, we don't want to shut down the whole radio. We want to pull boards in and out and keep the rest of the radio going, because sometimes one chassis could house 6 radios or radio equivalents. And what we did is develop a live insertion specification. So the Navy could plug boards in and out with the power on. And so we developed that standard, and it's actually in use today in various US Navy platforms. So we worked with the Standards Development Organization. So again, corporately, my company, MITRE, and therefore the government acquired an intimate knowledge of the technology, and we helped develop better radios and better equipment. It's actually a success story. We reduced a 6.5-foot rack of radios down to one standardized VME bus chassis, and saved the US Navy tens of millions of dollars in doing that. The other thing that we learned is by participating in a standard, you figure out very quickly, what do I have to do and what's an optional capability? And it's not always fully documented. But to participate, you need a strong personal commitment. I know I worked on standards a lot at night on my own time, and you need a corporate commitment in time and dollars, and the company has to be willing to dedicate the technical people to work on. Sometimes it was 3/4, almost a full-time effort to work on a standard, because when you show up for the meetings, you have to be prepared, you have to do your homework, comment on various drafts. It's quite a commitment. So what are the different organizations? There's ISO, International Organization for Standards. That's one of the large organizations. US, American National Standards Institute is a US member. You get one member organization per country. Been around a long time, since 1946. It came about after World War II when the US realized a lot of our equipment doesn't work in Europe, and we need some international standards. It's usually industry or government, some stakeholder that says we need to do this, and they operate by consensus. One of the most well-known ISO standards is the 9000 series for organizational quality management. A lot of manufacturing companies subscribe to the ISO 9000 series of standards. For computers and communications, it's a JTC1, part of ISO. It's the electronics engineering part of the ISO. They've done a lot of things like Motion Picture Experts Group, MPEG for video compression. Very well-known standard. Internet of Things, they're one of the main developers. A lot of work on IT security and cloud computing. So ISO is one of the biggest organizations. However, they are not under the UN. They're a separate organization. Under the UN is the ITU, the International Telecommunications Union. That's a UN specialized agency for information and communications. So you've got 193 nations, and you've got 800 private sector and academic institutions. Been around a long time, over 100 years, for international interoperability. Soon after the invent of primitive telephony, the ITU came about, and primitive radio. Three main areas of activity in the ITU. ITU-T for telecommunications. They do a lot of protocols for telephony. ITU-T was instrumental in making sure someone in the US or Canada could call Australia or the UK or anywhere in the world. They standardized the traditional telephony. Then they worked on video and audio compression, something I've used a lot in my career. How do we get high bandwidth video and audio over a low bandwidth pipe to a tactical user while preserving voice quality and reducing latency or delay as much as possible? The art of that is picking the proper ITU specifications. ITU-R, R is for radio telecom, so they define frequency utilization worldwide. What frequencies can GPS use? What frequencies do other users have to not use so they won't interfere with GPS is a very low power service. It actually operates below the noise floor. So ITU-R had to define a whole series of guard bands and basically keep out bandwidth on both sides of GPS. And now other services like GPS, GLONASS, Galileo, Beidou, all these international what we call PNT services, position, navigation, and time, they have to operate in a series of frequency bands around 1.5 gigahertz, and other high-powered terrestrial users have to keep away from those low-power services by a wide margin. That's all ITU-R. They're also defining some standards for the new, what we call 4K TV or UHD, ultra high def TV in the US, first developed in Japan. And then there's the one people don't know about, the ITUD. They develop standards and standards initiative for developing countries and emerging markets. They've done a lot of work in Africa, for example. IEC, International Electrotechnical Commission, they also do standards. You can see there's multiple organizations doing electronic and electrical standards. IEC's real forte is plugs, electricity transmission worldwide, solar energy. They're also doing IoT, Internet of Things. World Wide Web Consortium, an interesting group, W3C. They work on the higher layers of the protocol stack. They work on open standards for the World Wide Web, including hypertext markup language, or HTML. In the US, a big standards group is TIA, Telecom Industry Association. TIA works on cables and fire ratings and data center standards, even for labeling cables, satellite equipment and guard band. TIA fills in a lot of details that ITUR doesn't on the SATCOM front. They do a lot of work with mobile networks, cellular networks, a lot of work in the US. ANSI, American National Standards Institute. They work on thousands of standards. So the standards that I worked on for VME bus, this backplane bus with standard cards, that was for the VME International Trade Association, VITA it's called, and VITA is ANSI accredited to develop standards. So that's an example of an ANSI accredited standards organization. So they're the US representative for ISO and IEC. So a common misperception, ANSI does not write standards, they accredit standards development organizations. And kind of an anomaly is Ietf, the Internet Engineering Task Force. They are the largest, they're huge. When you go to the Ietf meetings, you'll see between 2,000 and 5,000 people there. They're huge now. When I started going, they weren't that big. It's a very influential, consensus-based standards organization. They meet around the world. There's been a problem at the Ietf. They've had trouble getting engineers, especially from China, into the US. China and Russian engineers who want to work on internet standards can't get into the US for the meetings, even when they apply months in advance. So Ietf is moving more of the meetings to other countries. So you've got network designers, operators, vendors. And I'll go into Ietf more as a case study in this talk. IEEE, that's where I started. That's the Electrical Engineering Institute. They do communications, networking, a lot of interesting technologies. They've gotten into robotics and healthcare. We use their standards for voice interoperability in Taiwan because they look at voice quality, and you can buy an IEEE compliant telephony test set. And it's great for settling arguments and voice interoperability when someone says, well, I can't understand you, your phone line is terrible. Oh, here it is, I've tested it with an IEEE accredited test set and it's good enough. And then we found out different languages, Chinese as an example, are harder. You have to use a higher quality phone line than you do for English. Just based on experience. ATIS has had a big role lately. ATIS is a telecommunications industry's standards body. They do a lot of work on 5G networks. They did 4G before that. They've done a lot of work. I've worked with them on threat analysis. So ATIS does work. If someone interrupts GPS, will it take down the cellular network? And if it does, what can I do? And ATIS is, and remember, all the cell phone carriers belong to ATIS, as do the cable companies. So what they've been tackling the last 2 to 4 years is, well, if we lose GPS, how do we keep the cellular network running in the absence of GPS? So ATIS has come up with better clocks and better solutions to make the cell network more reliable. Okay, let's talk about Ietf. It's been around since the 80s. It's a large open standards organization. They meet 3 times a year worldwide. They do a lot of work via email. If you subscribe to an Ietf standards group mailing list, you're going to get a lot of mail. And that's one of the challenges, keeping up with whatever standard you've chosen. You have to keep up with the emails, follow the discussions, read the evolving drafts, and you're expected to participate if you want to have an active role. It's open to anyone who's interested, mostly individuals. They come to know you, and that's where I mentioned earlier, it's very helpful to have a solid commitment from your company to keep going. The Internet Society is really kind of one of the governing and advisory groups running Ietf. So companies can join, a lot of individuals can join. I'm still a member. They work on internet use around the world. So Ietf is divided into different operating areas, such as routing, transport, security. Each area has an area director that helps guide the standards development. There are over 100 working groups. I think there's about 120 now. As I said, a lot of work is done via mailing lists. They make progress on their documents through the process of rough consensus. And what rough consensus means in real life is who shows up and who comments. That's who influences a document. They don't do formal voting the way the IEEE does. And the Internet Architecture Board defines the overall direction. They're kind of a series of thought leaders for Ietf, who provides broad direction and guidance. So they came up with this document, turned into a big deal, congestion control for voice traffic on the internet. As the telephony services transition from the old standard analog telephony to voice over IP, the internet was threatening to grind to a halt. And IAB came up with a good document and some guidance, and Ietf started working on standards for voice quality and how voice would preempt other less urgent data traffic. IANA has been in the news, the Internet Assigned Numbers Authority. IANA is a chartered organization. They assign and codify groups of IP addresses. Say, okay, the US gets these addresses for IPv4 and now IPv6. Different countries get different blocks of addresses. And it was in the news because there was a move to make IANA into a US government organization, and all kinds of countries boycotted and said, no way. It's got to maintain its independence. And there was a concern that if it was run by the US government, we could take away, for example, China's IP addresses and assign them to someone else, and there'd be chaos. So it stays independent, but IPv6, there's no problem. IPv4, the US was assigned so many years ago, decades ago, so many IP addresses, IPv4, that developing countries didn't get enough. And as those countries needed more and more IP addresses, they weren't there for IPv4, and that's one reason IPv6 was developed, a big reason. So this is a structure of what I was talking about. So you've got the Internet Society as overall board of advisors, and then you've got the Internet Architecture Board. There's a group called Internet Research Task Force, and they do more researchy, bleeding edge type topics. The product of the ITS is a RFC, a request for comment. It's actually their name for a standard. And under the Internet Engineering Steering Group are different areas such as routing, congestion control, cybersecurity. So I'll talk about the research side of this. We follow this being a federally funded R&D center. DARPA follows this. You've got work on encryption. As computers get more powerful, bad guys are breaking encryption algorithm used on the internet. So there's work on encryption, network management. This is just kicking off the quantum internet congestion control that I mentioned before, and then Internet of Things. So what is an RFC? I mentioned it before. It's just a name now. It did stand for Request for Comments. The current RFCs tend to be more formal. They're more like IEEE standards. There's over 8,500 of them. They've just exploded. There are different types of RFCs. The most formal are the standard track. Standard track are RFCs that we know are going to become standards. So there's a little bit more rigor applied. Before it's standards track, it's a proposed standard. In the beginning, it's a draft standard. So what it becomes finally is an internet standard after it's on the standard track. So they have their own process. There's also standards that are document RFCs that are not on the standards track. There's informational RFCs. Here's how to do something. Here's why it works. There's experimental RFCs. And then old RFCs that are no longer used, some of the original, what we call the below 1,000 series of RFCs are historical. They're really for reference if you want to understand the evolution of today's internet. A question I get a lot is, what does the Ietf control? It's rather nebulous. They typically leave the physical layer down at the bottom to the IEEE, such as Ethernet. Okay, so IEEE controls Ethernet. It then becomes an international standard rather than a US standard. And Ietf is in the middle with layer, say, 2 to 5, up to the session layer. And then you've got the World Wide Web Consortium that I mentioned and others controlling the top layers, what you see on your computer. That's traditionally, I'd say right now, the Ietf is moving up and down. Ietf defines capabilities I'd like to see out of Ethernet. They define how do I carry traditional telephony, what we call POTS, plain old telephone service. How do I carry that on an IP network? So they invented something called PWE3, pseudo-wire edge-to-edge emulation. And we use that a lot. It defines how I carry traditional serial lines, telephone lines over the internet. So that's an example of where they pushed downwards. They also define virtual private networks, and they define going upwards some of the capabilities that you'd like to see in services such as email. So they're also pushing upwards. So this is an example I like to use. It started off very experimental. My company was involved with this, delay or disruption tolerant networking. It started with the idea of we want an interplanetary internet. If we ever go to Mars, how do we get IP data to Mars? We need a series of relays. We need to be able to do this where we don't have constant connectivity. Some sites may connect, others don't. Your capability fades in and out, so very, very low bandwidth, high delay network. And how do we make that work? And that's actually turned into a series of standards now. Something evolved out of this called MANET, Mobile Ad Hoc Networks. And we actually use that in various radios. So it's good when you've got disjointed, non-reliable connectivity. How do I get IP networks to operate? Another one that I like is NTP, Network Time Protocol. I was involved in NTP version 4. Unfortunately, at this point, when my company pulled out of NTP version 4, there's really not that much US presence involved in it. It takes a lot of effort. I was devoting a lot of time, as were others in US DoD who wanted to make this happen. It took 5 years to get NTP v4 approved. It added authentication and encryption, backwards compatible with the older NTP version 3 that does not have those newer capabilities. But the encryption and authentication was critical. It says, how do I know that, let's say, US Naval Observatory is really disseminating the time over the internet, NTP over the internet? It could be some server in Malcolm's basement masquerading as an NTP server, sending out NTP version 3 packets. NTP v4 has a signed PKI cert from USNO that's embedded in my NTP client, making sure I'm talking to USNO, and once that relationship is established, using encrypted communications. So very powerful capability. NTP continues to be revised, and it's widely used around the world. It's not that accurate, but it works, and it's inexpensive. So how do standards help US and coalition partners? It tells industry and partners what the intentions are, where we're going, what is under development, and what products we can expect in the future. If your organization involves, it keeps you at the edge of technology. We knew where NTP was going a couple of years before it was common public knowledge. We knew where voice over IP or voice compression was. So you get this a priori knowledge of what's likely to happen. And that allows you to shape future policies and priorities. It helps you shape procurement decisions. So it allows DoD and our coalition partners to collaborate with industry. What DoD helped bring to some of these standards bodies is really an understanding of what's needed in a difficult communications environment, and how can industry codify that and make a family of products available so you can formally, informally influence a standards process to benefit DoD and our partners. We've actually done this. I've worked on a project with the Taiwan military, a foreign military sales project, and we knew certain standards were coming, and we specified certain equipment that we felt would be forward compatible with these emerging standards, because we learned once equipment is installed in coalition partner environments, it doesn't change very quickly, so you better pick your equipment carefully. So tips and tricks. Organizations and individuals involved need to realize development of standards can take a long time. As I said, 18 months for the hot swap standard, 5 years for NTP version 4. You have to plan that you're going to be in this for the long run. You have to pick which technical focus area makes sense, excuse me, and then which standards organization makes sense for you. What do you want and who should you go to? And then my recommendation, talk to the chair of the working group and look at their email trail and the draft documents and see if it makes sense based on your goals. What do you want to achieve out of this? What do you want to get? And realize that you're in this for a long haul. The company has to assign enough people, enough money, and enough administrative help for the duration of the effort. This is not a 3-month effort. Everything from travel budget to technical time, it all needs to be accommodated to make this work. As I said, it can take up to 3/4 time for a given individual to participate. Part of what is important is socializing the proposal to build consensus. You have to spend time talking to other people in a group, emailing with them. You have out-of-cycle teleconferences between the formal meetings where you talk face-to-face. So there's just time involved. You have to allow time to socialize. So just to conclude, standards allow US and our allies to be upfront, understand what emerging technologies are coming, and to promote this common approach and common understanding across many technologies and many programs. I use this all the time. We specified a series of standards for our points of presence, our telecommunications, what we call POPs, the points of presence in Taiwan. We have about 120 of them. We specified a whole series of Ethernet standards. It's not good enough to say Ethernet. You have, okay, this is a speed, let's say gigabit Ethernet using this fiber or this copper cable with these connectors. It's much easier when you really understand the technology and you've been involved with it. You also gain a lot of insider knowledge. It's not secret per se, it's just a lot of tips and tricks that you get from other companies developing the technology informally as you work on the standards. Oh yeah, we can do that, or you understand what the deficiencies are. So you have to pick the right standards development organization and the right kind of engineer to work on this. That's all I've got. Any questions, comments?
Difficult to change.
Yeah, it's a very good, the question was, because I don't know if everyone heard it, are there cases where older equipment could be software upgradable, including over-the-air upgrades? My response is it's much easier to do with today's equipment, things like software-defined radios and software-defined architectures. It's much harder to do with some of the older equipment where things are hardwired, whether in FPGAs or hardwired with discrete integrated circuits. It's harder to do, and some of our coalition partners, due to budgetary constraints, they keep equipment for such a long time. We're dealing with equipment that's sometimes 15, 20 years old. It doesn't have those over-the-air capabilities the way a modern piece of software-defined hardware does. So it's harder with the older equipment. It conforms to standards that were in effect at the time. That's what we designed. So the best you can do is say, for a gradual upgrade process, I need newer equipment that's backward compatible with this older equipment, and then I can gradually upgrade. And that's about the best you can do with some of this old equipment. Exactly.
They lend themselves to that. About 20 years ago, I think some of the FPGA-based equipment was theoretically developed with that capability. I just don't know whether any of it was ever successfully upgraded.
Yeah, not that I know of. It could exist, but I'm not aware of any. Bob?
Dr. Airst, you mentioned two primary categories of standards, the de facto standards that emerge from industry development and widespread adoption, and de jure standards that come from the various consensus and deliberative bodies. If you take a look forward, can you identify any emerging standards that seem like they're, currently on the horizon that Indo-PACOM or other, U.S. DoD, users and operators should be, studying carefully to understand what their implications might be and start planning, to either, influence or accept those as they emerge?
Yeah, it's a good question. I think there are Indo-PACOM defined programs for interoperability that they're more of the de facto type. This is what we're going to do. You want to talk to us. Some of these multi-enclave interoperability where you've got a gray enclave and you've got a series of approved encryptors, and then you, coalition partner, can come. A lot of those are de facto standards. Basically, Indo-PACOM's defining, here's what you've got to do to talk to us. And I think that's a lot of the way ahead for interoperability right now, but that's at a higher level, a series of pieces of equipment and protocols. At the lower level, all of that equipment is still compliant with the de jure standards such as Ethernet and radio frequency assignments and modulation types. So all of that, so you've got a combination. That's what I see going forward.
Will deployment of cloud capabilities on a more widespread basis, I was in the Jedi brief earlier, will that have any bearing or influence or considerations that need to be taken into account from from an interoperability and standards perspective as a follow-up question?
Yeah, another good question. So my concern about a lot of the cloud computing is reliability and resiliency. when you put your resources in a central cloud, how is it connected to all the users? Are there a couple of critical links that can be cut or degraded via jamming? Is there multiply redundant connectivity? Is it a highly resilient protocol at a higher level so it can handle error correction and strong encryption? So there's a lot of questions to be asked as you look at cloud computing and a distributed tactical environment. I've just got concerns about not that it can't work, but the way it's being implemented, and is it resilient enough? Right now, for example, a lot of ships have multiple satellite links on different frequencies, different bandwidths, and if the SATCOM doesn't work, they've got line of sight links of different protocols. And can cloud computing work on that DTN, that delay or disruption tolerant networking environment at low bandwidth, high delay? So cloud computing's got to be done properly. Otherwise, I see big risk looking ahead. In the rush to accept and adopt a new technology, you really have to think of the tactical user. It's got to be done right. Thanks. Any other questions?
Do you know whether or not ISA is still, do they develop or maintain some standards that are still commonly used? There wasn't one you listed.
No, that's DISA standards are another good example of interoperability that are de facto standards. You want to talk to us, this is what you've got to do. Just like GPS, right? And you codify what you want people to do, and they come. But if you look at a DISA standard, a lot of them call out standards defined by these other bodies that I mentioned. But you're basically setting up a profile of, okay, I comply with the following 20 standards, and then these two radios can talk, or whatever the multiple pieces of equipment can communicate. Sure. Anyone else? Okay. Thank you.
All right, thank you to our attendees who waited around until the bitter end today, and thank you, Mr. Airst, so much for coming and sharing your time and your knowledge with us. In appreciation for the time that you've given us. AFCEA will make a donation to the Toys for Tots Foundation in your name, and AFCEA Hawaii would like to present you with a chapter coin. Great. Thank you so much.
Thank you.
All right, thank you very much. This is our last session for today. We'll be back here for the workshop sessions at 10:30 tomorrow morning with a session on coalition interoperability and security on AWS. Thank you very much.